background from my colleagues just to have more light for you in the morning. Part of the joke, I'm Lucas Magali. I'm part of the L4MS project. I'm from Politecnico di Milano. I'm assistant professor there. I cope with all the research topics related to the Industry 4.0 in our research group at the Department of Management, Economics and Industrial Engineering. I'm an industrial engineer. And I'm going to present you some basic theory of material handling. I guess you are, of course, quite expert of material handling. If you are here, it's because you have already proposed something very interesting from this point of view. But because we are going through then later a lot of material, a lot of training material about robotics, about the platform, about the tools that L4MS is going to offer you and that you have to test. I wanted just to show you some few elements and few points about traditional issues about material handling. Why? Because the risk is that we focus then too much on the technological part, on the robotic part, and we miss instead also to highlight in what you are going then to deploy the advantage for the company where the solution is implemented. And this is also very important to consider. So let me go ahead with the presentation. So some basic definitions. So, well, material handling, let's say, is the art of moving, packing and storing products. Basically, we focus on moving products in our project. And material handling should be, let's say, the efficient process for the short distance movement, and should usually, if not compulsory, takes place within the buildings. So this is important to be considered. So we don't discuss broad logistics, but we focus on specific activity and the use of robotics for these specific movements within the building. So why it is important? It is important because it is not just a movement of product. So it's not just move product from A to B. And if you want to show the advantage of this movement, it's not possible just to say I replaced a person. Because all in all, the new tools we are going to offer allow to deploy cheap solution, allow to save some cost, but on the other hand, is anyway quite a costly solution because you have to consider the robot, the implementation, etc. So the important part is that also to highlight how the logistic can be coupled with the process that the logistic is supporting, that material handling is supporting, meaning the production. So we must consider the scheduling of production control. I have a microphone open. Okay, thank you. We have to consider the added value to the product cost in the sense that we needed to provide benefits for that. Of course, we need to highlight how the effectiveness, the efficiency also can be improved in the plant layout. So it's important somehow to highlight also this aspect. There is always, let's say, 4 dimensions. Well, we can say there are many, but movement, time, quantity, and space. So we have to consider the movement that we are going to consider. That it means the from to matrix typical that is created. So we have to consider the points from which we move the material. The time dimension is important because we can move the entire batch of product in one single time, or we can move every minute, every hour. We must consider this. We must consider the frequency and the time that is needed for the movement. And it's important to consider that the human activity is not going to be replaced by robot directly. Let's say it's not that because a person now is moving with a cart certain material every hour, the robot is going to move every hour. This can be different, and you must also be innovative in this kind of possible proposal. And the quantity, well, the quantity can be different and must be designed in the proper way. With the traditional cart, with the traditional forklift, you can probably move a huge load. But with other robots, you can just move a few kilos sometimes. So it's also important to consider that the quantity is going to change, the way you manage the frequency of the movement is going to change. So basically, it's also a different way to design the logistic process, the material handling process. So this is also important, and this is common when you are going to introduce a new equipment, a new technology. Is not the technology replacing the same function of the previous solution. The previous solution must be, let's say, revised and improved, and then you can apply the technology. Space is also important. Space is important because we want to save space, and space in our case is also important because this kind of robots also need to consider the space and the layout in which they move around. So this is also a particularly important. Objectives clearly is to lower the cost per unit, but also to reduce the manufacturing cycle time. So to increase the rhythm of production, or anyway to create a certain efficiency. Even if we don't reduce the cycle time, even if we don't reduce the handling cost, sometimes it's fine also just to better control the flow of material. So nowadays, tracking the movement of the product in the shop floor is very important. So clearly, if the products are moved in an automatic way, this is going to be very important if we can track it in this way. So we can provide better working conditions because robot can improve safety. We can provide certain contribution for better quality because this tracking can help. And of course, if we introduce also fully automated material handling, avoiding also operators to cope with the product, in principle, we should let's say, decrease the risk of a possible error of the person. All in all, this can increase the storage capacity that is important in some for some business and for some production. And we have again have to reduce cost. I guess the focus on the cost is always on the table. But what is important nowadays is the control of the flow. Factors that are affecting are then the production problem, human element involved, and the, let's say, the capabilities of the handling equipment. And the capabilities of the handling equipment are also partially improved by our project or are anyway strongly related with our project. So the equipment, meaning the material handling equipment, so the automatic guided vehicle, robots, etc., we can consider, must consider space requirements, as we say, must consider speed of the equipment, adaptability to the space. Some solutions are more rigid, some other are more flexible. Of course, we are also considering flexibility. So we both consider situation in which we design the solution to be flexible to certain different possible cases, like different mix of production, production campaign, production scheduling, etc. But it's also possible to adapt the solution to a different working condition that was not forecasted while we designed the solution. Load capacity. As I said, we must also consider that we are not going to replace a forklift with a robot, but we can also think that we can change the load of the equipment, power that is needed, depending on the type of movements we have to use to carry out maintenance that is part of cost, and okay, then if the supervision is required or not, depending on the plant, depending on some parameters, depending on the equipment, and of course certain aspects related with the environment, meaning if the equipment is can move in a certain environment, if there is a problem due to the type of battery or electricity, because there are gases in the system, etc. So there are also certain particular cases, probably not in your case, but generally speaking. Equipment are storage and order picking equipment. Generally speaking, we focus more on the transportation equipment. So we have, of course, forklift, trucks, etc., carts. We focus in our project on certain specific robot that, again, if you are here, you are expert on this. Human factors, so safety of personnel must be considered when designing the solution. So certain characteristics for the navigation of the objects of the equipment is important. And well, there are capabilities of the manpower and also the task that we assign to the manpower considering the solution we are going to design. So if there is an interaction between the humans and the robot, or if it is a fully automated solution. Production problems are about volume of production that is going to be moved, the type of material that must be handled, and the layout of the plant and the building. Sometimes the layout is neglected, so you have a poor layout, and on a, let's say, a bad design of the layout, you put a innovative logistic solution. Sometimes there is a constraint, so you cannot change the layout of the plant. But sometimes there are some solutions that can improve the layout before taking care about the material handling. And clearly this means having the right, let's say, the identification of the flow of different materials. So then your solution might probably improve the movement of just one product, that in this case will be just one color of this. And in the schema you can see different colors for different products. The squares in the layout are the different machines. And the different colors are the different products, and the quantity is represented by the thickness of the line. So having this first explanation of the layout can help a lot to show which is the movements you have to realize in the layout, and so which is the improvement that the solution can provide. It's important that you highlight also this aspect. It's not the main part, because the main part is related with the implementation of the tools, and you're going to have a lot of training about that. But this is just to say we are not forgetting that there is a big issue before the technological implementation. So there is a big effort also in the design of the logistic solution. There is a big effort in the identification of certain equipment, in the identification of the products that must be moved, the flows, the material, the frequency of movements, etc. We expect you to have already consider these aspects and to be able, by coupling the technology implementation and this aspect, to show the benefits that you can provide. Benefits is not, again, just the change from traditional material handling to innovative one, or if it is just so, you must be able to prove that if there is no improvement in terms of efficiency of the material handling, at least there is a good way to track the flow, to monitor the flow, and you have a better control on it. And that's it from my side. If you have questions, I just keep this last slide. So with the, let's say, objective, as I said, so better control of the flow of materials for the one key aspect for the future. Thank you.